Today you are going to learn elimination reaction and basically E2. Let us first discuss about the characteristics of E2 reaction. So let us write the first characteristic. First characteristic is that E2 reaction is a single step bimolecular reaction. It is a single step bimolecular reaction. Second, it is a two-order reaction. Now, why it is a two-order reaction? Because the rate depends upon the rate determining step or the slowest step. The slowest step involves Rx and a base. Involves Rx and base. So here you get 1 1. So the order is 2 for elimination or E2 reaction. So now in E2 strong base is always used. In E2 strong base is always used. There is a transition state in E2 and the major product in E2 is the one which is most stable and more substituted. So, what are the characteristics of E2 we have seen? It is a single step bimolecular reaction. It is a second order reaction. In E2 strong base is always used. There is a transition state. And the major product in E2 is the one which is most stable and more substituted. And the major product in E2 is called set Z product. We'll learn about it. What is set Z product? We'll learn about it. One more or two more. In E2, no carbocation is formed. In E2, no carbocation is formed, and E2 order for tertiary. For tertiary, it is the highest. This is tertiary. This is secondary. This is primary. Tertiary is the highest. For secondary, second highest. For primary, it is the lowest. See, unlike E1 reaction, there is no formation of carbocation in E2. The E2 reaction rate order is 3 order. Sorry. And the E2 reaction order is for tertiary it is the highest, for secondary it is second highest, and for primary it is last. Now Let us see the mechanism. We have learned all the characteristics of E2 reaction. Let us see the mechanism of E2 reaction. Suppose I consider here HCH2 HX. Now I told you for E2 a strong base is always applied. Now when a strong base is applied, it will always want H plus. A strong base always wants H plus. So this one will attack this one and take this one. A strong base will always want H plus one. So what happens here is R is R CH CH2. There is H. There is X. This H will want to go. This H will want to move away from this compound and go with the strong base. As a strong base 6H more than the compound. Okay. When the H plus will want to go from here, then it will want to form a bond here. Here it will want to form a bond. So suppose H plus is leaving. Suppose H plus is leaving. H plus is leaving. So there will be formation of a partial double bond character. There will be formation of partial double bond character. Now you see, here carbon is having 5 hands. This carbon is having 5 hands. So 5 hands. 1, 2, 3, 4, 5. So it will tell that halogen leaves the group. Due to the presence of 5 bond, this one will leave the compound. This one will leave the compound. So what happens then? As the X is leaving, there is a formation of delta minus. Both of them are leaving from the group. This is known as the transition state. See, I am summing up from the first. We apply a strong base to this. And a strong base wants always H plus. A strong base wants always H plus. So it will want this H plus from the compound. So H plus needs to go. When H plus will need to go, then it will form a bond here. So while leaving, a partial double bond will be formed here. When a partial double bond will be formed here, this carbon will have 5 hands, which is impossible. So this halogen will leave the group. So what happens? X is also leaving, H is also leaving together. So there is no formation of carbocation or all that. Again I am telling, when we apply a strong base 6 H plus, so H plus needs to go, When the H plus will go, there will be formation of partial double bond here. Due to the formation of partial double bond, this carbon will have 5 hands, which is impossible. So it will tell this halogen to go away. So this is known as the transition state, or the baby alkene stage, or the baby alkene stage. Okay, from here finally what will be formed? R CH2. Clear? What will be formed? RCH2. This one will be final. So summing up from the first, once again, a strong base is applied. It will want to take our H plus. So the H plus will leave. So there will be formation of partial double bond. Due to the formation of partial double bond, this carbon will have 5 hands, which is impossible. For this, it will tell this X or the halogen to leave. So there will be formation of delta negative here, while these two are leaving. So this is known as transition state or the alkene state. So from here the final product will be formed RCH double bond CH2. This is the final product, RCH double bond CH2. And always remember in E2 the solvent is polar protic solvent. What is the meaning of protic? Protic means presence of H plus. Aprotic means absence of H plus. E2 is always, in E2 the solvent is always polar protic, and the word protic means here the presence of H plus. See, H plus is present, and aprotic means absence of H plus. Okay, so let us now see what is Sedzev rule and apply it in example of E2 reaction. We are going to learn Sedzev rule and apply it in E2 reaction. Let us now take, suppose I take bromine and I apply alcoholic KOH as a base, strong base. So in E2, we are taking an example of E2 reaction. This is Br, we are applying alcoholic KOH. So what will be formed here? Alcoholic KOH will always see hydrogen. So where Br is attached, this one will be alpha, this one will be beta, and this one will be beta. So there can be loss of H plus from this or from this. So what are the two probabilities that can be found? This or this. When there is a loss of H plus from this beta, this one is found. This one, then this one is found. So which one will be the major product? Which one will be the major product. Now to identify this, you have to learn Sedzev rule. You have to learn what? Sedzev rule. Let us learn, not learn. Now let us learn Sedzev rule. What is Sedzev rule? Sedzev rule. Sedzev's rule states that haloalkanes on being heated haloalkanes on being heated with alcoholic KOH. Haloalkanes on being heated with alcoholic KOH gives more substituted product as major product. Sedzev rule tells us that haloalkanes on being heated with alcoholic KOH gives more substituted product as major product. So here, which is more substituted? Then more substituted here is this one, and this one is less substituted. So this one will be major and this one will be minor, and this one is Sedzev's product. This one major, this one minor, and the minor product will be called as Hoffman's product. And it will be called as Hoffman, and the major will be Sedzev. So now we have learned what is Sedzev's rule. Let us now revise again. Sedzev's rule is stating that haloalkanes on being heated with alcoholic KOH gives more substituted product as major product. So in this example, I'm explaining you again. This one is alpha carbon, this one is alpha carbon as bromine is attached, and if this one is alpha carbon, then the beta will be closest to it. So it is closest, this one and this one, so both are beta. So there is a probability of H plus from this as well as this. So when there is a loss of H plus from this one is found. When there is a loss of H plus from this one is found. Now according to Sedzev's rule, this one is major because it is more substituted and stable, and this one is minor because it is less substituted and less stable. So the major product is known as Sedzev's product and minor product is known as Hoffman's product.